Okay, hello again, ladies and gentlemen. What I'm going to do is I'm going to finish up these helpful hints examples for you, so if you're on the right track for what you did yesterday. Um, Also, what you should do is download and take a look at that Pathways to Success for Proofs, because that will give you a good idea of what the wording should sound like for each one of the reasons that you give, for the stuff that you come up with. Okay, so all right, so this one, ABC, angle ABC is a right angle. Okay, so what does it say about angles 1 and 2? Okay, angles 1 and 2. Well, angle 1 and 2 must be complementary. Angle 1 and angle 2 are complementary. Okay. Okay, and the reason is, okay, definition of complementary. By definition, two angles are complementary if they add up to 90 degrees. And since this tells you that there's a right angle, then that makes those two complementary. Okay. This one, AB is a straight line. Okay. What's that going to make 1 and 2? Okay. Angle 1 and 2 are a linear pair. Okay. They're a linear pair because they are adjacent and the non-shared side form a straight line. So they're a linear pair, making them supplementary. Okay. So you can say angle 1 and angle 2 are supplementary. Did I spell that right? Yes, supplementary. Okay, supplementary. Okay, and the reason I'm going to give is going to be that linear pairs of angles are supplementary. Supplementary. Okay, linear pairs of angles are supplementary. Okay, see, this is a straight line. If this had said it was a straight angle, okay, then we could say by definition of supplementary. Okay, says it's a straight line that makes it a linear pair, and linear pairs of angles are supplementary. Okay, so slight difference there, but there it is. Okay, so this one, triangle ABC, BA, and it's marked here. So lots of times in the diagrams it'll already be marked. Okay, but here BA is going to BC. So what does that tell you? It tells you a couple of things, right? First thing it tells you is that angle A is congruent to angle B. Okay, angle A is congruent to angle B. Okay, because in a triangle, the angles opposite congruent sides are congruent. Okay, in a triangle, the angles opposite congruent sides are congruent. Okay. All right. And from that now, since we have the sides congruent, I can say triangle ABC is isosceles. Okay, triangle ABC is isosceles. Why? That would be by definition of isosceles. Okay, that's a definition of an isosceles triangle where the two sides are congruent to each other. So I can say definition of isosceles. Okay. So now, this next one looks exactly the same. Okay, except now it's telling you the triangle is isosceles. Okay, So since it's telling me that the triangle is isosceles, I don't have to say it's isosceles. It's already told me that, so I don't have to say that again. Okay, and I can basically say the same thing I said up here. Okay, that the angle A is congruent to angle B. Okay, I can say that again. Okay, angle A is congruent to B. Just to save some. I'm sorry, it's A and C. Sorry, I said B. It should be C here. That should be angle C up in the one above it, and then this should also be C here. Sorry, my mistake. C. Okay. Because now since we've been told that the triangle is isosceles, I can use the fact that it's isosceles in my reason. Okay, so I'm going to say base angles of an isosceles triangle are congruent. Okay, base angles are congruent. All right, so that's what I can say there. Okay, now for triangle ABC, for this one, now that we're given the other piece of information, now we're given that the angles are congruent to each other. So we can basically say the converse. Okay, this is going to tell me now that BA is congruent. I'm just going to start abbreviating. BA is congruent to BC. Okay, now I'm going to say basically the converse of what I said up here. Up here I said in a triangle the angles opposite congruent sides are congruent because I knew the sides were congruent and I stated the angles were. Okay, down here I know the angles are congruent right here. The angles are congruent. I can say the sides are. So I'm going to say over here in a triangle the sides opposite congruent angles are congruent. Okay, so that's what's called the converse of this other statement. Okay, it kind of switches them around. Okay, one I was given the sides so I can say the angles are congruent. One I was given the angles so I can say the sides are congruent. Okay, so what's important about that is all those pieces, both sides and both angles, have to be within the same triangle in order for that to work. And then that's an isosceles triangle. Okay, and then I split this into two because now I can say that triangle ABC is isosceles. Okay, again, now since I've already said the sides are congruent, here I can say by definition of isosceles. Okay, I'm really starting to abbreviate a lot here, so you're free to abbreviate if you want, as long as I understand what the abbreviations mean. Okay, ISOS would be okay for isosceles. DEF for definition would be fine. Okay, PERP or the perpendicular sign for perpendicular, you can start abbreviating. Okay, just to make things a little bit easier. Okay, now what does this one say? ABC BD is the altitude. Well, what does altitude tell you? Okay, if I have altitude here, what does that tell me? Okay, remember what an altitude is. An altitude is a segment drawn from a vertex perpendicular to the opposite side. Okay, so since that word altitude is used, okay, that's going to tell me that angle BDA and BDC are congruent right angles. Okay, so that's what I can say because that's an altitude. Okay, or congruent right angles. This is by definition of altitude. Okay, since altitude specifically says it's perpendicular to the opposite side, those must be a right angle. By definition of altitude, those are right angles. Okay, I can also say triangles BDA and BDC are right triangles. Okay, they're right triangles. Okay, that's by definition of right triangle. Okay, they're right triangles with an angle in it. Right up here, I said they were right angles. That makes those two right triangles. Okay, and last on this ditto, okay, BE is a median. Okay, so again, what does median say? What does a median mean? Median means that it goes from the vertex to the midpoint of the opposite side. So in this case, it tells me that, okay, AE is congruent to EC. Okay, and again, by definition of median, since by definition it goes to the midpoint of that side, okay, I can say by definition of median. Okay, by definition of median, it goes to the midpoint. Okay, so then I can say that's why those two are congruent to each other. So that's it. All right, so that's it for the rest of this. Okay, hopefully you're kind of getting the hang of it. It's not that difficult. It's just something you need to get used to, and it comes with practice. Okay, so what I'm going to do is I'm going to post another ditto for you to work on for homework as some more practice. A lot of them might be very similar to the ones we've already done in the notes. Okay, just think about them, write the statements, write the reasons, and you'll be in good shape. All right, till next time. See you later.